Welcome to this explainer. If you came into this thinking offshore fabrication is just about cutting and welding steel, you are going to leave seeing the yard as a massive, unforgiving logistics machine. We're skipping the basic intro today and dropping right into the staggering scale of offshore heavy lift logistics.
Okay, let's dive into this. Just picture an 8,000-ton topsides module being lifted completely clear of the quay in a single massive pick. The scale here is literally hard to wrap your head around. A person standing next to this thing looks like a tiny 2-pixel dot. But here's the secret. That 8,000-ton pick, it's not done for the spectacular. It's done because every single module you can lift whole is a module you didn't have to assemble piece by piece, high up in the air, on a schedule you absolutely cannot recover if things go sideways.
To really grasp this, we have to look at the alternative, which is stick-built assembly. This means hundreds of small, separate lifts with scaffolding everywhere, like 80 meters up in the air. It's slow and, honestly, it's dangerous. Compare that to modular assembly, built entirely at ground level. It is so much faster, it's safer, and it's way easier to inspect. And then, you make one heavy lift to put the whole thing into place. Basically, heavy lift cranes buy you the ultimate trade in an EPCI schedule, converting highly dangerous work at height into totally controlled work at ground level. So that brings us to the crane window constraint, which is really about when the machinery itself dictates your schedule. The yards that actually win this fast-track work, they have the heavy infrastructure to pull it off. Integrating these massive topsides and cantilever modules calls for extremely high-capacity floating cranes, specifically in the 8,000-ton and 3,600-ton classes. But here is the massive reality check. These cranes are never, ever just sitting on standby waiting for you. They are booked across a yard's entire order book, sometimes literally years in advance. Their availability window is a fixed, non-negotiable hard date. They are, hands down, the absolute hardest constraint in the entire schedule.
And this brilliantly illustrates what we call the missed sailing problem. Think of a fixed yard crane slot exactly like a container ship's sailing schedule. If a truck arrives at the port 10 minutes after the gate closes, that cargo doesn't just lose 10 minutes, right? It loses 2 solid weeks waiting for the next ship, because ships just don't wait. Well, heavy lift cranes operate on that exact same unforgiving logic. Missed your window, and you don't wait a few days, you wait for the next slot in the yard's crane program, which might be a full quarter away. There is zero partial credit for being yearly ready. Which leads us straight into the 97% rule, or trading tidiness for time. All right, I want you to put yourself in the shoes of a project director under serious pressure. Just look at this scenario. Your module is 97% complete, but your one and only crane window opens tomorrow. So what do? Do you lift the module right now as is, or do you hold the crane for 3 days to neatly finish up that last 3%? So the absolutely crucial point here is, you lift it. You complete that final 3% in place, even if it means doing it 80 meters up in the air at a massive productivity penalty. Why? Because that penalty is measured in days, whereas the penalty for missing your crane window, that's measured in months. In the yard, the crane program, not the drawing program, sets the hardest dates. You never ever trade a crane slot for tidiness. The crane window is fixed, your module completion is the variable. Let's move on to multi-rig resource drift and the domino effect we saw on the CAT-J program. So when you're building a whole series of assets, you quickly discover a huge problem that nobody puts in the original plan. Resources do not stay where you assign them. They naturally drift toward whichever unit is in trouble, which is almost always the lead rig. On the CAT-J program, which was this major series of harsh environment jackup rigs, rig number 1 spent way too much time removing obstacles during derrick erection, and every single hour of that overrun quietly pulled crews, cranes, and supervisors away from rig number 2. Suddenly, the follow-on rig is slipping behind schedule, not because of its own engineering or supply chain issues, but simply because it was second in line and completely starved of resources. Now let's look at how the yard mitigated rig number 2's delay, because it is an absolute masterclass in project management. Instead of just trying brute force and scrambling to hire more people, they completely changed their method. For rig 2, they deployed an 800-ton Goliath gantry crane that runs on rails directly over the build area. This gave them full uninterrupted crane coverage and completely wiped out the stop-start erection problems they had on the first unit. Better geometry and smarter logistics will be raw effort every single time. All right, moving into the manpower reality and how to actually read the ramp-up curve. Now, what's really interesting about this is that the ultimate leading indicator for a project's health isn't your steel tonnage, it's the manpower ramp-up curve. If you plot your planned headcount against your actual headcount week by week, and that actual curve lags, that is your early warning system flashing red. By the time your overall progress S-curve actually flattens out, which usually happens 1 to 2 months later, the window to recover your schedule is already completely gone. The manpower lag confesses the truth long before the official progress reports ever do.
And we need to be very specific about what manpower actually means here. The true constraint almost every single time isn't just general labor. It's certified welders, specifically welders qualified to 6C or 6G standards. You absolutely cannot hire these highly skilled professionals at short notice, and there's no way you can train them at short notice either. Plus, every other regional yard is fiercely competing for the exact same tiny talent pool. Make no mistake, this specific welder shortage is the #1 killer of the offshore progress S-curve.
To really anchor this constraint in your mind, think of a super busy restaurant on a Friday night. The bookings are your schedule, and the kitchen staff is your workforce. If your kitchen is totally backed up at 8 p.m., you can't fix the problem by adding more tables or taking more bookings, right? You fix it by hiring more cooks in the morning. It's the exact same in offshore fabrication. If you don't mobilize that certified workforce early, you simply don't get to serve. Which leaves us with this final, vital question for any project manager or engineer analyzing an EPCI project. When you look at your reporting, are you just reading the superficial schedule completion percentage? Or are you actually reading the oxygen supply, the real, unforgiving flow of available cranes, certified welders, and cleared work fronts? Because out here in the steel world, space might be negotiable, but resources and time never are. Thanks so much for joining me for this explainer, and remember to always keep looking past the paperwork to see how the real machine actually operates.